time to review. You can do it. Woo! Woo! All right, everybody. I just wanted to get you guys amped a little bit before we start with this video. All right, I told you in class today that the video got deleted. So what I'm going to do is I'm going to show you my answers, show you kind of how I got my answers, but I'm not going to be able to really start from scratch. Okay, so let's take a look at the first one. It is a radical. I know you guys are not really comfortable with radicals, but radicals basically take a quadratic and invert them on their side. So everything in a radical moves right. It moves horizontally. So normally when you do a quadratic, remember when we plot our quadratic, we go up 1 over 1, up 3 over 1, etc. Well, with a radical, instead of increasingly going up, we're going to increasingly go to our right. So this is a vertical stretch, of course, but as you're moving, the graph is going to increase horizontally to the right. So what happens is instead of going up 2 and then up 6, remember I told you had to multiply that by 2? What you're really going to do is keep going up 2. So you're going to start here at 3, 4. So you're going to go up 2, but instead of going up 6, now you're going to just continue to go up 2, but move horizontally by going right 3. Then you're going to go up 2, right 5, etc. So that was how I was able to come up with my graph. It has a vertical stretch by a factor of 2. You go right 3 and up 4. These points here are the points for the parent graph. So you're going to stem everything from these points. Alright, so we have no vertex because remember vertices have to have 2 sides, so we have no vertex. The domain goes from 3 all the way to the right to infinity. The range goes from 4 and then up to infinity. This graph is constantly increasing. So the x values that I use to make this increase go from 3 and it continues all the way to infinity. So that's why my domain and my increasing interval are the same thing. Decreasing interval is none because this graph never decreases. So remember, for your intervals, always look at your domain. I'm going to say that again, domain. Always look at your domain, your x values. Alright, left end behavior, it never is actually going to approach negative infinity, so it's none. The right end behavior, as it approaches positive infinity, the graph continues to increase to positive infinity, so there goes your answer there. There is an extrema. It's a minimum point at y equals 4. It is neither even odd, and that means it has no symmetry. Alright, on to the next one. Alright, there's a lot going on here, and I'm not going to erase a lot of it. This is your absolute value graph. You should have started the graph at 0, 8, because it's a transformation that goes up 8, and it has a vertical shrink by a factor of 2/3. And because there's a reflection over the x-axis, your graph should be upside down. So if you look here, we start at 0, 8, and then you should go down 2, right 3, down 2, right 3. On the other side, down 2, left 3, down 2, left 3. So by the time you're done, you've created your absolute value graph. It has a vertex, because a vertex must have 2 sides coming from that dot, and the vertex is at 0, 8. Domain is all real numbers because it constantly goes to the left and constantly goes to the right. The range is from negative infinity, which is down here, and it stops all the way up here at infinity. I mean at 8, sorry. Okay, so it stops at 8. The intervals, remember I said earlier, it has to do with your domain, okay? It has to do with your domain. So you're taking this domain here and splitting it in half. Okay, so you're going to have one part of the domain starting with negative infinity and the other part of the domain ending with infinity. And these numbers here are replaced by the first number in the vertex, okay, which in this case is 0. So that's how you write your increasing and decreasing intervals. Now you just have to decide who's increasing and who's decreasing. Well, this graph increases when the x values are small. Okay, so it's increasing when you have small x values. So the small x values start at negative infinity and wind up ending at 0. So that means this one is the increasing interval. Then the numbers on the x-axis start getting bigger all the way to infinity as the graph goes down. So that means your x values are getting bigger when the graph decreases. So that's your decreasing interval. Okay, so that's how I got those two answers. All right, the left end behavior, you know that as it approaches negative infinity, what's the graph doing? You're looking at your arrows. So it's very important for this section that you look at your arrows. Look at your arrows. So since the arrows are both pointing down, they're both going to go to negative infinity. This does have a maximum value at 8. Make sure you put y equals 8. Now, you see that the graph right here, this yellow squiggly line, is telling you that it goes through the y-axis. So because it is symmetric on both sides of the y-axis, it's even. So remember, anytime it's y-axis, it's even. All right. Number 3, a lot written down again. This is a quadratic. It starts down 6, and then you go to the left 1 for the vertex at -1, -6. It has a vertical stretch by a factor of 3, so you can tell here that the graph is stretching up more than the original graph. So the vertex is at -1, 6. The dot has two sides coming from it. The domain is negative infinity to positive infinity because it goes from both sides, left to right. So that means that my increasing and decreasing intervals are going to split the domain. And I'm going to replace the split with the first number in my vertex, which is -1. So now I have to decide, well, where am I decreasing, where am I increasing? So on the first side, I'm decreasing. The graph is coming down. As the graph comes down, the x values are small. They're negative. So since the x values are negative, I'm using the numbers that go from negative infinity to -1. So from negative infinity to -1, that means the graph is decreasing. So for these x values that are smaller, my graph is coming down, it's decreasing. Then it turns and starts to increase. And then the x values are getting bigger. They're getting more and more positive. So as your x values get more and more positive, the graph is getting bigger. So that would be your increasing interval. So that's a good way to split it up. Remember again, your intervals are based off of your domain. Left and right end behavior have to do with your arrows. So since both of my arrows are pointing up to infinity, that is what my left end and right end behavior will be. Okay, there is an extrema. There's a low point here at -6, so make sure you put in the y. Now, right now, you can see that the graph is not going through the y-axis, but if we translated it back to the original spot it would have been, you see right here that it does go through the y-axis. So because of that, we say that it has y-axis symmetry, which means that it's an even function. All right, the next one is also a radical. Now this radical only goes up 4 and has a reflection of the x-axis. So in order for it to be a reflection of the x-axis, I'm going to start up here at 4, and instead of going up 1 over 1, I'm going to go down 1 over 1. Now the progression for a root goes, usually is up 1 over 1, up 1 over 3, up 1 over 5. So it's the complete opposite of the quadratic. So because it's the opposite of the quadratic, the way we're moving to the right increases. So you see here, because it's a reflection of the x-axis, I'm now going to go down 1, right 1, down 1, right 3, down 1, right 5. So these values increase instead of the y values that you're used to in a slope. So I went down 1 over 1, down 1 over 3, down 1 over 5. That's how I made my graph. Alright, there is no vertex because we don't have two sides. The domain starts here at 0 and goes all the way to infinity. The range starts here at 4 and goes to negative infinity. But because you must write in order from smallest to largest, that's why the negative infinity comes first, because this has to be in order. There is no increasing interval. This never increases, but there is a decreasing interval. It's the same as the domain. There is no left end behavior because it never ever goes to negative infinity. It never hits there. But it does go to positive infinity. And remember, if we're looking at our arrows, you see that it's going down to negative infinity. There is a maximum point at 4. It's neither even, odd, and that means it has no symmetry. Alright, this part is fairly simple. There was a mistake in some of the stuff that was written. Anytime you see a shrink, if it's a shrink vertically, then you should see the fraction right away. If it's a shrink horizontally, then that means that there's going to be a 4 inside, but you're really shrinking by 1/4. So they had to just be careful. So that's why I put a 1/4 here. So it says that it shrinks horizontally by a factor of 4. So I did that. That's my shrink horizontally. Then it says it's reflected over the y-axis. That's here. And then it said that it shifted left 7. That's here. Okay, TL, that's translate left. Okay, so reflected over the y, shrink horizontally, and translated left. And everything we do is based on this formula. Remember, A tells you about your vertical stretch or your vertical shrink. Also tells you about your reflection on the x-axis. The B tells you about your horizontal stretch, horizontal shrink, and your reflection on the y-axis. H tells you whether you're going to translate left or translate right. And K tells you whether you are translating up or translating down. Okay, so let's take a look at the next one. I wrote that it says a stretch vertically by a factor of 7. So here's my vertical stretch. Reflected over the x-axis must go in front of the F. So there you go there. Shifted right, so that's a translate right to, and then here's your translate up to. Alright, next one. And you don't have to write these little ones. I'm just showing you how I got my answers. Alright, the next one said it's reflected over the x and the y-axis. So here's my reflection of the x. It always comes before the function. And here's my reflection of the y. It always comes before you start anything else, inside the parentheses. And then after that, it says that it stretched horizontally by a factor of 10. So here's my horizontal stretch. Notice how I made it a fraction. Remember, inside the parentheses are always opposites. So that means that if you stretch you should have a fraction inside. If you shrink, you should have a whole number, because everything in the parentheses is opposites. And then the last thing said that it shifted left 7, so here's my translate left. Alright, the last one says that you shifted left 2, so here's my translate left. And then you shrunk vertically by a factor of, it should have said 1/3. So if you shrink by a factor of 1/3, here it is, so that's my vertical shrink. And then you reflect it over the y-axis, so here's my reflection of the y. It's always right in front of the x inside the parentheses. And then you also went up 6. So going up 6, that's translating up. Okay? So I know I went over that fast, but just check your answers and make sure that you have the same thing I do. Alright, so, I'm going to erase this one because it looks kind of crazy. So we have a piecewise function, and you have 3 different ones. Whenever you have, this is called a compound inequality. So whenever you have a compound inequality, you should always just plug in those numbers. Make life easy on yourself. Before I do that, I actually want to get the numbers in my domain that are my barriers. So the first one was at -8. Then I have -4. Then I have 0. So these are the 3 areas where you're going to be graphing. One of your graphs may be to the left or in between. Another graph may be in between. And then the last graph will be to the right. Okay, so we will not have any graphs to the left of -8. So the first one, I'm going to call this A. For A, I'm going to plug in -8. And I get 24 minus 15 is 9. So I can make a coordinate by taking this as my x value, that's my y value. Now I'm going to plug in 4, -4. And I wind up getting 12 minus 15, which is -3. So I can make a coordinate with -4 and -3. Now, there is no line here, so this is going to be an open, unincluded circle. And there is a line here, so this is going to be a closed, included circle. So now at -8, 9, I have an open circle. And then at -4, -3, I have a closed circle, and then I can just connect the dots. Now I'm just drawing extra dots based on the slope so that it makes it easy for me to connect the dots. If you have a straight edge, you can just connect from that dot to that dot. Alright, that's graph A. Graph B, we're going to do the same thing because it's a compound inequality, so just plug in -4 and plug in 0. So 3/4 times -4 is equal to -3 plus 8 is equal to 5. So that is the coordinate -4, 5. Because there's no line, it's going to be open. Next one is 3/4 times 0 plus 8. 3/4 times 0 is 0 plus 8 is 8. So that's the coordinate 0, 8. There's no line here, so that will also be open. Yes, you are allowed to have 2 opens. Okay, so I'm going to go to -4, 5. Make an open circle and then go to (0, 8). And make another open circle and connect those open dots. Okay, our last one I'm going to call C. And for C, I don't have a compound inequality, so I'm actually going to have to do the transformation. So the transformation, I know here, based on this, that it moves right 2 and down 3. It is a quadratic. So I know my quadratic goes 1, 1, 2, 4, 3, 9, etc., 0, 0. So that's what I'm going to base it on after I move. So from the center, I'm going to move right 2 and down 3. So this becomes my new center. So I'm going to go up 1 over 1, and then go to 2, 4. And then go to 3, 9. Now if you notice, it says x is greater than or equal to 0. So this is my 0 line. So I need to graph everything from here and to the right. So I don't need to draw anything else on this side. Notice everything is closed because it starts included and then it keeps going. Alright, so these are our 3 piecewises. Alright.